Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to explain or teach. So, what is the center of mass and what is the center of gravity? And these both are coincide at a point or not. And some of the regular shape of means the center of gravity values for the sum of the regular shape of the bodies. Mostly these topics I will be covered in this part video from the chapter of gravitation in 9th standard level. So let me come to our topic. But once again we discussed it. So in our previous video, so we clearly discussing that can we measure a weight of a freely falling body? That is nothing but simply weightlessness of an object. In the topic, so we clearly discussing. And also I hope everyone will be understanding. If an object is in the rest position along with the elevator, at that time the real weight or actual weight is always equals to the apparent weight. Actual weight is nothing but if the gravitation force is acting on the body. Apparent weight is nothing but normal force is acting on the person opposite to the gravitational force. That is one. But when the elevator is moving vertically upward, is nothing but the person is in the motion along with that elevator. The acceleration of an elevator is less than the acceleration due to gravity. At the time, you are observing that our weight, apparent weight is increases. Is nothing but when you go to move up vertically upward, our weight is increases. But really our weight is not increases, but apparent weight is increases. Next, second one, if the person is moving vertically downward with less than the acceleration due to gravity, at that time our weight is decreases. But when if a person is moving vertically downward, not only the person, if an object is freely fall from certain height, at that time, so our acceleration means acceleration of the person or acceleration of the body is equal to the acceleration due to gravity, because of in a freely falling body, which force is involved? Only the gravitational force is involved. So that's and that cases for every 1 second how much acceleration is changes? 9.8 meter per second. That's why so we feel weightlessness is nothing but at that time the weighing machine is showing the zero reading. Is nothing but you are massless or not massless, you are the weightlessness. That is the way of the method to measuring the weightlessness of object. Now we come to our topic, next one. Center of mass. It is simply represented by the symbol of C. Center of mass is nothing but, so actually so much information is there about this one, but these topics we discussed in +1 is nothing but in the first year a separate chapter is there about this one, so we discussed clearly in that one. But in the 9th standard, no need of that much of information to you. That's why simply I will go according to your standard level only. So we know that every object is made up of tiny particles. Each particle has a mass, that is that. That's why if you can take any object, that object is made up of number of tiny particles from one end to another end. So every particle has the mass, but the whole mass of the every particle is concentrated or located at a particular point. That point we are called center of mass. Listen very carefully. Center of mass is a point where the entire or whole mass of the particles of a system or body is concentrated or located. That one we are called center of mass. For example, in case of 30 centimeter scale, just So from 0 centimeter to 30 centimeter end, so it is made up of the plastic. Is nothing but number of tiny plastic particles are combined together and form that one. We know that. But so the 30 centimeter scale, you try to balance it at the different positions. But exactly at 15 centimeter position only, it will be balanced on the both sides. Is nothing but. So from 0 to 30 centimeter, particles are there. Each particle has the mass. But what will be happen? The entire from 0 to 30 centimeter of the total particles are balancing where at the 15 centimeter only. That point is called center of mass. Once again listen, the point where the total or entire or whole mass of the particles are located or concentrated at a point. That point is called center of mass. That is one is it. So this is the first one, and second one is center of gravity. It is the G simply. Center of gravity. C of M, center of mass. C of G, center of gravity. C of M, we can say that it is the C of G simply. C of G. C of center of mass, center of gravity. Gravity is nothing but weight. Means earth attraction. Sorry, gravity is nothing but earth attractional force. We know that. So the body is, for example, if we can mention the 30 centimeter scale, it is the 0 centimeter. It is the 30 centimeter. Like this one. So it is a 15 centimeter. So the body will be exactly balanced at where 15 centimeters. That's why this is the center of mass. We can set that. But from 0 to 30 centimeter, we can set the some particles, mass of the particles like this. Like this. Each particle has the mass, and we know that if an object is on the earth or above the surface of the earth, so that object must be pulled by the earth gravitational force in the downward. It's nothing but the earth attractional force is acting on the mass of a body, that is called weight. That's why here you are considered. So this is the M1 mass of the particle. This mass of the particle is M2, M3, M4, M5, M6, M7. That's why totally 7 mass of the particles. You can set that among the 7 particles, the total 7 particles mass is located or concentrated where at M4 point. That's why M4 we are called center of mass of the entire system or whole body. Like the same way, this M1 is pulled by the earth towards its center. It is the earth, just you can say that for understanding. It is the center. That's why it's nothing but simply like the center. Every mass of the particle is attracted by the earth, gravity towards its center. That's why it is the center of the earth. We can say that center of the earth. So M12 up to M27, every mass of the particle is pulled by the earth gravity towards its center. But finally, so if you are observing that, so the line which is slightly passing through the mass of the particle and center of gravity, so that is what is that one, M4. That's right. So M4 is the center of mass and as well as the center of gravity. It's nothing but the total weight is also balanced where at the M4 only. So the straight line which is passing through the position of the object and the center of gravity, center of the earth, that line, in that line, which mass of the particle is there, or which weight of the particle is there, that is the center of gravity. So most of the cases, according to the mechanics, to solving the numericals or problems, Okay, you are considered the uniform density of the spheres or object. That's why in case of the uniform density of the object, okay, center of mass and the center of gravity both are coincide. If the mass, okay, density is non-uniform, at that time both are not coincide. Listen very carefully. But most of the cases, okay, so according to the mechanics, center of mass and the center of gravity are coincide. We can say as a single point only. Here is also, so M4 is the center of mass and M4 is also center of gravity. That's why okay, center of mass and center of gravity is located because of it is a uniform scale. It has the uniform density because of this made up of the plastic only. So once again, listen. What is the center of mass? Center of mass is a point where the entire or whole mass of the particles are located. That point we are called center of mass. It is denoted by the symbol of C of M. Center of gravity. So it is a point where the whole weight of a system or body is located. That is called center of gravity. It is represented by the symbol of Cg or denoted by the symbol of C of G. According to the mechanics, you are considered the uniform density of the object. That's why center of gravity and the center of mass are coincide, are located at the same point. It is nothing but center of mass and center of gravity is the same only. Now we are discussing that some important values about the center of gravity of the objects. Position of CG, center of gravity. Position of center of gravity of different shape of the bodies. Different shape of the bodies. So first one, simply square or and rectangle. At intersection of diagonals, you are observing that square and rectangle shape is there. It is the square shape, it is the rectangular shape. Now, so we draw the diagonals where these two diagonals are meted. That is the center of gravity. For this one, to finding, so general regular methods are there. I will give a brief idea to you. But so in the rotating motion concept, in intermediate, it means in the plus one. So about this one also, how we can find the momentum of inertia, that is also we can find easily. But anyway, leave it for first of all. So in case of square and rectangle, it is the square, it is the rectangle. That's why. So in square also, center of gravity is present at the intersection of diagonals. In rectangle also same as that one is there. Next second one. triangle. In case of triangle, like this, A, B, C. This is the C. So that's why where at the intersection of medians. That's right, at the intersection of medians. That's right, where these three medians are meet, that is the which one? Okay, center of gravity. Next, the third one. Uniform hollow sphere or solid sphere or solid disc or hollow disc. Anyone? Okay, like this. Okay. Or uniform ring, like this one. Or okay, simply I will write uniform hollow, okay, sphere or solid sphere. It is a sphere. So the sphere is maybe either it is a hollow or solid. During such condition, where the center of gravity is located? At the centroid of sphere. Centroid is nothing but center of mass. At the centroid of sphere means exactly at the center of the sphere only. Next, fourth one. Uniform solid disc or disc, simply uniform disc better. Uniform disc. Say at the centroid of disc. At the center of the disc or at the centroid of disc. Uniform ring. Say at the centroid of ring. So in uniform disc, at the centroid of the disc, centroid is nothing but center of mass. In uniform ring, at the centroid of ring. Next, in cylinder. It is a cylinder. It is a cylinder. In this one, in this cylinder, just you draw the two imaginary lines at the upper and lower portion. From that one you are considered it is an A, B, C, T. A, B, C, D is appears like a rectangular shape. For this one, you draw the diagonals. It is the C. That's why at intersection of diagonals of cylinder is nothing but when you are consider the cylinder in a cylinder. So if you can construct it, and which one rectangular shape. So in rectangular shape we know that where the two diagonals are meet at that point CT, center of gravity, is present. That's why in this one also we are considering like that. That's why at the intersection of diagonals of cylinder in the considered part of the rectangular shape. Next, seventh one is the it is a hollow core. It is the core. We know that it is the base A, B, C. BC is the base, A is the vertex. A is the vertex and BC is the base. So in this one, you are observing that direct line from the base. So means the center of gravity is located in case of hollow cone. 2h/3 from the vertex and h/3 from the base. So from the base at h/3 center of gravity is located. So at 2h/3 from the vertex center of gravity is located. So listen, from vertex at 2h/3 at from base at h/3. Understanding? So center of gravity is located h/3 from the base to h/3 from the vertex. In a solid cone, h/4 from the base. h/4 from the base. Solid cone. So where center of mass is located at h/4 from base of the cone. So listen, what are the position of center of gravity of different shape of the bodies? In rectangle and square, the center of mass is located at the intersection of the two diagonals. In triangle, at the intersection of the medians. In case of uniform disc or uniform solid disc or hollow disc, the center of means at the centroid of the disc. In case of uniform ring, at the center of the ring. In case of uniform sphere, that is either solid or hollow sphere, at the centroid of the sphere. So in cylinder, at the center of the two diagonals or intersection of the two diagonals, not at the intersection of the two diagonals of the cylinder. In case of solid cone, h by 4 height from the base. In case of hollow cone, h by 3 from the base, 2h upon 3 from the vertex. These are the position of the center of gravity of the different position of the objects. These values, these are very useful for you for the part B mainly. Okay, but sometimes they are also asking for the 2 marks also. At that time, better to draw the diagram, and so means this is the name of the object. It is the diagram, is nothing but figure. It is the position of the center of gravity. Like that one you can write neatly in the running notebook also. So thank you.